Hello everyone, welcome to Clashing Coder. So in this video, we will see the question that is swap nodes in pairs. So this is a linked list based question, and it has been asked in a lot of interviews for many companies, for the FANG also, and for other companies as well. So this is a medium level question. So let's see the problem statement. Then we will see how to solve this and different techniques, and then at last I will show you the code for this problem in C++. So let's see the problem statement. So given a linked list, swap every two adjacent nodes and return its head. So it is saying that we are given a linked list. So linked list is 1, then 1 is pointing to 2. So it has a value and a pointer. So which is pointing to the next element 1 to 2 and 2 to 3 and 3 to 4. And we have to swap every two adjacent nodes. So we have to swap the nodes in pairs. So that is 2 will be swapped with 1, 3 will be swapped with 4. So you can see the output will be 2, 1, 4 and 3. So these two elements are swapped and these two elements are swapped. So and return its head. So head will be now swapped, head will be 2. So 2 will be swapped with 1 and it will become the head. So we have to return the head. And you must solve the problem without modifying the values in the lists node. That is, the nodes themselves must may be changed. So that it is the question says that we cannot change the values, so we cannot change the value in this node by changing it with 2 and this with 1. So we have to change the actual nodes or swap the actual nodes and change the links between them to give this output of the swapped nodes. And let's see the constraints on this problem. So it says that the number of the nodes in the list is in range 0 to 100, and the node value will be from 0 to 100. So this won't be any useful for the value. This you can simply actually we don't need this constraint. So let's see. So I can think of one case actually. You can see we have to swap the elements in pair. So if what if we get the odd linked list, this is for the even. So for even you will have every you will have each element for every element. That means you will have a pair, equal number of pairs. But if you have, you can see the, let's see these cases. So in this case you can see we are given an empty linked list, so we will simply return empty. And for this one, so it is an odd case, so we will simply return 1. So that means that if we are given a number of nodes in a linked list is odd, then we will swap the even number of elements, but the odd will remain as it is. So what I'm trying to say is, if we are given 1, 2 and 3, so there are 3 elements, so we will swap 1 and 2, but we will leave 3 as it is. So output will be 2, 1 and then 3. So that will be one of the case. So let's see how we can solve this question. And also, if the interviewer, when interviewer will tell you this problem or ask you this problem, then if he may not tell that you cannot change the values, then you can start the problem by saying that you can actually change the values in the nodes without swapping them. So you can start with that problem. Then he will give you the constraint that you cannot change the values, but you will have to change the links or the actual nodes or swap the actual nodes. So then you will start with the problem, the actual solution. So let's find out how we can solve this. So I've made this representation. So you can see this is our input 1, 2, 3 and 4. These are the pointers. 1 is pointing to 2 and this is the output that we want. 2 should point to 1, 1 should point to 4 and 4 should point to 3. So let's see how we can do this. So actually, if you see how we can make this output, so we will have to process nodes in pairs. So if you see, we cannot start the processing the linked list as one linked list. So we'll have to process first two nodes. We'll have to change the links between 2 and 1, and this will also involve actually changing the link between the third node also, which will not be swapped in this pair, because the new node should point to the next node. Otherwise this link will be lost, this 2 pointing to 3, if we swap this 1 and 2. So let's see how we can do that. So if you have solved a reverse linked list, so you may get the idea of how to solve this. But if you see now, what we have to do is we have to do 3 steps. So first we have to swap the link between 2 and 1. So we have to change these two here, and this 1 should point to 3, so it should point to 3. So this is a simple thing that we have to do. But for doing that, if you see, so if we do this, so we will lose the pointer to 2 actually, the pointing the node pointing to head. Basically we need the head also. So what we can do is we can simply create a new dummy node which will point to the head. So this is a dummy node which will point to head, and I will tell you the solution, which will be a simpler one. We can simply use 2 pointers to solve this problem. First we will create a header node, new node, dummy node you can say, and we will keep we will make a new pointer which is previous pointer which will point to this header node, and we will make a current pointer which will point to the actual or the original head node. This is our current pointer. So now first step will be our first step will be to change the pointer between the previous node to the 2 because this needs to be head. So at last we will not return this dummy node, we will return dummy.next which will return the actual header or the actual linked list. So let's see. So first we have to swap or we have to change or cut this link and make it point to 2. So this previous should point to 2 because 2 will be the starting of the new linked list or what we have to return in the output. So to do that, you can see the current is pointing to 1. So previous should point to current's next. So this is previous next which should point to current's next. So our first step will be to cut this link. So we can simply will do previous dot next should point to current's next. Then again now we have to do the next step because basically we change this pointer. So one is also pointing to 2 and previous is also pointing to 2, so we don't need this link. So you know that in the output one should point to 3, not the not in the output but in the first step one should point to 3 because we will have to change this 2's pointer to 1. 2 should point to 1 in the output, so we need to some node which should point to 3 to maintain this as a single linked list, not break the links. So let's see how we can do that. So basically if you see, previous is pointing to 2 and 2 is pointing to 3, so we need the 1 to point to 3. So how we can do that? So basically if you see, previous next is 2 and 2's next is 3, so we can simply change the link by changing this current's next. So current's next should point to this previous next dot next, so then this link will become, so this will be the new link. So now we don't need this link will be this link will break, so you can see this link will break. So now we have done two steps. We have changed the pointer from previous to 2 and then 1 to 3. So now we need this 2, this is useless now. You can see 2 is pointing to 3 and 1 is also pointing to 3. So we need 2 to point to 1. So see, we can simply do that by, you can see, by changing the link using same previous pointers next, that is 2, and 2's next which is this link should point to current. So this will point to current. Now our linked list will become like previous, this is previous 2, 2 is pointing to 1 and 1 is pointing to 3 and then 3 is pointing to 4. So this now this is the previous, here is our current. So this is the first step. Now we have to again perform this step to reverse these links as well. So for that we can simply do that, we will have to simply change the pointers. We have to do this all this in a loop. So let me also write the steps, so I will copy the steps also, so it will now let's see the this steps and see run it on do a dry run on this example. So first we will create so I have not written that step, but we will create a dummy node which whose next will point to the original node that we will have to return as output. So dummy node will point to 2 at the end of this loop, so that we have to return. So we will create a dummy node which will point to 1 and we will create a new pointer, that is previous pointer, and point it to the dummy node first, and then the current will point to the head node. You can see this will point to the head node. So now when we start this loop, so you can see current is not equal to null and current's next is also not equal to null. So current's next is also not null and this is also not null. And why we are checking these two conditions? As I have already told, this is for the even case and this is for the odd number of nodes. If there are odd number of node, so current is not null but current's next is null. So there that means that 1 is there but 2 is not there. So we cannot swap single element. So we will simply return 1. So this loop will actually not return, and this is also the base case. So before writing this condition you will have to check if the head is null, then simply return the head. If head's next is also null, then also simply return the head. So we will, if there is no element, then return head. If there is a single element, then also return the head, because we cannot swap a null element or we cannot swap a single element. So let's continue the try run. So you can see these conditions are satisfying, so our while loop will run. So previous next will point to current's next. So previous next is this, so this link will break and it will point to current's next. So current's next is 2, so now it is pointing to 2. So now in this next step you can see the current's next will point to previous next. So previous next is, you can see previous next is 2 and 2's next is 3. So this link will break. Current's next, this link will break. So we will simply break this link and it will point to 3. So you can see we have done 2 steps. So we have broken this link and one is pointing to 3 and previous is pointing to 2. Now we will follow the third step to point the 2 to 1, because 2 is also pointing to 3 and 1 is also pointing to 3, which is not useful. So now we will remove this link and you can see previous next. So which is previous next is 2 and 2's next was 3. So we will make this to point to 1. So now we have done these steps. Now our output is, you can see previous, and it is pointing to 2, 2 is pointing to 1 and 1 is pointing to 3 and 3 is pointing to 4. Sorry for the handwriting. So yeah, so 0 is pointing to 2, and you can see we have successfully swapped these two nodes, and we will have to continue doing this for all the other nodes while the condition is true. So to do that, what we have to do, you can see these two steps are for actually incrementing the pointers. So this previous should point to now the current. So current is 1, as you know current was pointing at 1. So previous should come at 1. Okay, previous will come at 1 and the current will go to current's next, which is 3. Current is here and now it will point here. So now you can see, now here you can see the previous is at 1 and this current is at 3. Now same steps will occur. Now 1 will start pointing to 4, which is current's next. Previous will start pointing to 4, and then the this 4 will start pointing to 3. And first of all we will break the link. Basically current's next, which is 3 4. So 3 will actually start pointing to previous next, which is null here. So 3 is pointer will point to null because 3 is at last element. So this is not pointing anywhere, you can see in the output. So it will be becoming null. In this condition this 3 will point to nothing, so it will become null. So it will break. Now 2, we have to now point this 2 is pointing to 4, you can see, and 3 is null. So now to point this 4 to 3, this is the condition. You can see this is the step. Previous next dot next, so which is 1's next 4 and 4's next, which is null, will now point to current is on 3. So 4 will start pointing to 3, and at last we will get our output. You can see sorry, this is not this will be 2 1 and yeah 2 1 4 and 3, and at last when these loop ends we will simply turn previous next as the output. So output will be previous next. So the time complexity actually for this will be O of n, because you will be simply traversing the linked list one time. So the time complexity will be O of n, and the space complexity will be O of 1. It will be constant because we are not creating any new linked list. So we are simply swapping the links and we are creating just a constant, or you can see just a new pointer, so which is counted as constant. So it will be same for any length of the linked list. So let's see the code. I hope you understand this. So let's see the code. So code will be in C++. So I've already written the code, so I will explain you. So it will be similar to the algorithm that I have shown the steps. So you can see, so this is our function in which we have to write the code. So we are given the head, so it is of type list node, which is having two values, value and the next pointer. So now we will check if head is null or head's next is null. So these two conditions are for these two cases. You can see the base cases are already provided in the question. So if it is null, so we will simply return the head, which will be null only. And if there is a single element, then we will simply return the head also, again held, because we cannot swap the single element. So you can see now we will create this new, first of all we will create a dummy node. So this new head is a dummy node, so it will point to it will, yeah, here you can see this previous. So previous will point to new head, as I told in this step. So yeah, so here you can see previous is pointing to the first, it is pointing to this dummy. So we have initialized it to dummy node, and the current will point to head. So head is 1, so current is pointing to 1. So now we have to start our loop while current and current next is there. So this is for the even case and this is for the odd number of nodes case. Now we will follow our 3 steps. First we will break the pointer, or we will make the previous point to the current's next. So this pointer will start pointing to 2, which is current's next, and then we will break the link between this current's next and we will make it point to the 3, which is 2's next actually, or you can say previous next. so it will point to 3 now. And now again, we have to as we have to change this 2 and 1's pointer also, so we will make this 2 point to 1. So that can be done by previous next, which is uh, previous next 2, and 2's next is this link was broken and we made it to point to 1, which is current. Then again we have to continue for other nodes as well, so we will increment our pointers in each iteration of this loop. So previous will come to current position and current will go to the next element, and again the same steps will solve. And at the last we will simply return this dummy node. This was a dummy node, so we don't have to return this, so we'll return dummies next. So now let's submit this question. So I will also provide the code in the description, so I will highly recommend you to first solve this problem yourself and code it, and then if you are not able to, then you can go through the solution and then write the solution yourself again. So you can see it was submitted successfully, and you can see it is faster than 50% of the solutions, and it took less memory than 7.6% of the solutions. So I hope you like this video, and this was a iterative solution. And if you want me to make the solution for the recursive way, then please write down in the comment section. I will also make the video for the recursive solution. Thank you for watching, guys. Do like, subscribe, and like share this video with your friends. Thank you for watching.